Hello and welcome today, folks. We are doing something just a little bit different. I got a comment a little while ago on my video here about this heap sort that was using a JavaScript implementation. They mentioned that there was a bug in it, and I was looking at the code, and honestly, I didn't see anything I liked. I think this code is at least 2 years old. Knowing what I know now, I would definitely do things differently. There is an issue that is inefficient, so the bug that was mentioned is really more about efficiency, but I thought I would go back and actually look at my old code and refactor it into something that I would maybe do nowadays, and so that's what we're doing today. I will be working in VS Code, so you can use whatever editor you want if you want to follow along. So what I want to do is make a proper test suite and then actually run that. I'll be using something called Jasmine.js, which is a module for testing. And then I'll also be kind of showing you how to install that and get it working. And then we're going to actually kind of go through the process I would kind of take on now to refactor this code in a way that makes a little bit more sense. All right, let's do it. So here I'm going to open up a terminal and we're going to navigate to a place that we're going to create our working folder. I'm going to go to documents. I have a place called glitched failure for my glitch failure videos. We're going to go into data structure. So we're going to go there. I'm going to make a directory that I'm going to call heap sort, and we're going to call this the refactor because I'm refactoring it. All right, let's cd into heap sort refactor, and I'm going to open up VS Code. All right, I get this, and yes, I do trust the authors since I'm the only author, and of course it's empty, so there's not much going on here. So the first thing I want to do is kind of port in the code that I wrote last time. So if I go back here, I'll provide a link for this. There's a gist for this, and so I'm just going to copy all this. So I'm going to get the raw, I'm going to copy that, go back here, go into this folder here, MinHeap.js. All right, MinHeap.js, we're pasting that, and that looks good. At the very bottom, you can see I wrote some tests. These are not very good. I'm going to actually delete these because I'm not going to be using these. I'll be making better tests for this. Let's save that file, and now we have the old code that I want to change here ready to go. One thing I'm going to do, let me make this a little bit bigger so you all can see what I'm doing. So one thing I can do, besides having my terminal like this, VS Code is really nice because it allows you to have an integrated terminal. So I'm going to actually open that like that here. And here is basically the same thing, but it's within the IDE. So that's pretty cool. So there are a few things I want to do. First is I want to make sure that I'm going to have my node packages set up nicely. So I'm actually going to create a package.json file. So it's called package.json. All right, and that will be basically empty for now. It says JSON, but it's nothing going on right now. And I want to start installing some packages, specifically Jasmine, because that's what we're going to be using as our testing library. I'm going to mention Jasmine.js. And so if you kind of look at that, this is Jasmine where you can install it here. I don't need to save to dev. npm install Jasmine. Okay, and so you'll notice that it did two things. It modified my package.json and made it a dependency. And it also created a node modules folder where it actually stores all of the packages and all their dependencies, which has usually their own dependencies. So it can be kind of very massive and large. So I have Jasmine now ready to go. I do want to also install something called Jasmine Console Reporter, which is a funny name. And I'm going to kind of go here. So Jasmine Console Reporter. The output for Jasmine when you run your tests is not very pretty, and so this Jasmine Console Reporter thing just makes it look better, and so that's what I want to do. So I'll just copy this install code here, and I'll run that here. Perfect, and now it's in there. I would normally just kind of go ahead with this, but one thing I noticed is that the code I'm writing is going to be using ES6 because that's what I like to use. It's more modern, it's better, I think. It's a little bit more readable. There are some issues you're going to find that Jasmine actually works with ES5, and so it won't understand any ES6 stuff, which is a problem. We need to make it kind of understand what we're writing. So we're going to be using Babel to actually do that. Babel is a transpiler. Basically, it's going to take our ES6 code and kind of like rewire it to look like ES5, which Jasmine can understand. Babel.js and to install, and we can look at that. We have a choose the tool. I'm going to be going with a Node because that's what we're using. So click on Node, and it says you can just install here. Again, I'm not going to save to dev. I'm just going to just install it directly. So I'm going to paste that there. I'm going to get rid of the save to dev thing. Just don't need that. And we're going to install Babel core. Okay, so that is now our dependency, and now everything should basically kind of start working. We do need to make some modifications here. So you'll notice that we now have a bunch of other stuff in our folder where we have node modules, package lock, which is basically keeping all the dependencies and their versions and all that good stuff set up. And what we need to do now is, and I'll go back to the Jasmine, you'll notice it says, okay, after you install it, you should add Jasmine in your project by initializing it. So we need to do this npx jasmine init and kind of show you what that does. And it ran really quickly, and all it did was create a folder called spec. In that folder is another folder called support, and in that is something called Jasmine.js, and that is just a configuration for setting up your Jasmine. We have basically the spec folder where all the tests are supposed to live in the folder called spec, which is, again, we just made that, so that's already there. The file should have spec.json at the ending, so we'll have to keep that in mind. And if we have any helpers, which we will because we're using Babel, so we do need to actually have helpers for that. So something else that we're told to do is set Jasmine as your test script in your package.json. So I'm going to actually copy this, and in the package.json, we need to add that as its own key value pairing. And so put a comma and save, and it nicely formats on save. So now when we run npm test, whatever word this is, it will use this command to actually execute on whatever you're testing. And so if I do that right now, npm test, it's going to try using Jasmine as it did here. It saw that there are no specs, and so nothing happened basically. So it's working. Just we need to make our spec. So let's do that real quick. In VS Code, I think click on this, and that's the folder I'm in, and I'm going to make a file. And I want to make it minheap.spec.js. It's not in the support folder, it's in the spec folder. So just keep that in mind. And if we go back to the getting started, I can click on, I think, docs. Let me see, docs. And your first suite, and you can just kind of like, it kind of explains what's going on here. I'm just going to copy this first test right here and pop that into our first test file. Okay, so this is just checking to see if the value true is actually true, which of course it is. So if we run our test now, npm test, it says, hey, it ran with 0 failures. Well, what you'll notice is that this output, I'm sure you probably can't see it, but it's like a little green dot, and that's kind of it. So that's not very pretty. What happened to our pretty package? Go back here to package.json. When we run test, npm test, it's actually just running whatever is in here. And so we need to actually specify this Jasmine console reporter. I'm just going to copy that, put it here, a space, double dash reporter. So it's an argument for Jasmine basically, and we need to specify what we're using as that. And I'll just paste that and save. So if I run my npm test again, it will look a little bit prettier, and that's kind of what I'm looking for. So it kind of shows you like the full test, the main test, and then each individual test, how long it took to run, how many passed, how many failed. Okay, so right now we are set up with our testing suite. We have a test running actually. Let's actually think about how we're going to set this up. So I'm going to close out our JSON files, and I'm going to actually separate our spec from our code. Okay, the thing to remember here is in JavaScript, whenever you want to export something to be used somewhere else, you have to actually explicitly say this is being exported. Default export class, or I think it's export first, export default. Okay, export default class, and then here I can actually import that. Import MinHeap from, oh, it looks like I had a little auto generation there. Okay, cool. So it's importing MinHeap from, and if you think about where the spec is, it has to go like out and then find it here. So that makes sense that it's kind of relational. I'm going to be able to have access to the MinHeap class. And so in here, let's actually do a little bit better with these tests and kind of explain what's going on with this. And you'll notice that I don't need to like import Jasmine for everything to work, right? Because Jasmine is kind of like the context that this file is being run in. You don't need to define this describe function that's already built out and defined by Jasmine, along with the it function and the expect function. So it sounds like a weird name for a function, but the idea is that this is written kind of like an English sentence. You can say a suite, well, it contains the spec with expectation, or something like that. So in our case, the describe is actually kind of like a umbrella for the scope of tests that you want to run. So in this case, I only care about the MinHeap, so I would actually just put that as like the umbrella scope for what we're running on. So I'm going to put here MinHeap. Okay, MinHeap, and what should it do? Well, let's see. There's a bunch of stuff it has, but I think I'm gonna just pick one right now. I'll call peak. So instead of this, I should say it has a peak method. I'm gonna save that. What does peak do? Peak should pick up the top smallest value, and so actually I'm going to kill that, and I'm going to actually use my MinHeap. So I'm going to say const heap equals a new MinHeap. And I need to provide an array. I'll just actually define one here. And I'm going to call it 321. Your tests do not need to be super complicated, by the way. The idea is that your test should be, as simple as you can get it. I think I like the idea of keeping, just feeding in the array like that, basically. I know that my current implementation does not do that. Like, I don't have a constructor that does that right now, so I will need to change that. But I want to write the test first. Okay, you write the test first, see if it fails, and then if it fails, then you fix it. That's how test-driven development kind of goes. So that's what I'm going to be working with right now. I'm going to assume in my test, okay, the heap, if it's working properly, it has a peak method. Heap.peak. This should give me the value 1. So I want to expect. We expect that dot to be the value 1. Save that. I'm going to go here, and I'm going to run my test. Test. And it looks like we got a failure. Let's see what happened. The import did not work. Okay, so what went wrong with my Babel? Because essentially that's what's supposed to be doing it. Okay, so you know what? I think I know what the problem is. I forgot to do one thing, which is in our Jasmine JSON. So I'm going to go there real quick. So in our Jasmine.json, we need to define a helper. In our case, the thing helping us is Babel. So we need to actually tell it, go to Babel and have it do with what it's supposed to do. I'm kind of just copy and pasting it here, but basically it's going to go to the node modules folder, which is what we have here. It's going to go into the Babel module, go into this index.json, and that's what it's going to use to help Jasmine do what it's supposed to do. Now I'm going to save that and cross that out for a second, and I'm going to run my test again. And it did not work. Fantastic. The issue here is it's kind of telling you here, it says to load ES module, you set the type module in the package JSON. So that's what we should do. So in here, we're going to add another key value pairing, in this case type, and the value is module. And that's what it's basically telling us to do. So I'm just following what the error is telling me to do. Let's try to run the test one more time. And it did not work. It said it couldn't find this import. MinHeap. Oh, I think I didn't put .js. So .js, because it's a file and it goes by the file. So if that works. Okay, so that worked this time. Okay, so that was my issue. So that looks like it's working. Well, it's not working because it says MinHeap has a peak method failed. The reason it failed is that there's an error. Heap is empty. So the issue here is that when I instantiate my MinHeap, I'm assuming that when I supply the array, it's actually like populating the heap, but that's actually not what's happening here. Our constructor does not allow for that. So what I'm going to do here is modify this, and this is, again, test-driven development. You make the test. Once it fails, you go back, you make sure you do whatever it takes to make the test now pass. So what I need to do here is make sure that I pass in an array. So I'm going to pass in the array here. I don't want to just make this array, because I need to actually insert and make sure that the heap functionality is actually working properly. So for each value in the array, I want to actually do an insert. So that's what I'll be doing. And so now let's run our test again. So it's saying that, so now it actually did work. Now it's saying the expectation was failing. It expected 2 to be a 1. So for some reason, we're getting a 2 instead of a 1 from the peak method. And I think I know the issue, because right now our peak method is not really looking at the very top, and that's the problem. So this is one issue. This is one bug that was in my previous implementation. When I do peak, I need to make sure to return the first value, which is the top of the heap. I'll save that, and I'll run my test again. And now, oh, green check marks. Oh, this is the beauty of it all. Let's see what else we can do. One thing I will also note is I really have issue with me not having any kind of documentation in my implementation. Okay, so that's nice to have. One thing I don't love is that I'm using these terms in ways that they're typically not used when you're talking about heaps. Like insert, I guess insert is used. I also typically hear push and pop for these kinds of data structures. So one thing I think I'll do here is I just want to rename this to not insert, but to push. So this is really just changing the name. I want to first make a test for that. So let's do that. And I'm going to say it has a push method. Okay, and we can keep this code here just fine. And let's say that we now have a heap.push, and we push the number 0. Then if we peek that value should now probably bubble up to be a 0. So if I push, then this should work. I'll save that. And if I run my test, unsurprisingly, it's going to fail because heap.push is not a function. Oh yeah, because it doesn't exist. So I'm going to go back here and I'm going to rename the symbol, which is what you can do in VS Code. Basically, you name it differently now, and it will change all other places where it is found. So I'm going to say push. You see how it like automatically changed up there. Okay, so let's run our test again. Okay, beautiful passing, very, very nice. So I'm trying to keep my MinHeap as simple as possible in terms of implementation. There's so many things you could do with it, but for its just simplicity, I'm just going to keep it as I want to initialize with an array. I want to push values onto the heap. I want to pop the top value from the heap and peek at the top value. That's it. Let's add a little bit of documentation for this push method. For that matter, I also want to add some documentation to the peek method. Okay, so we have a test for the push, we have a test for peek. Now we need a test for popping. Okay, so we can say, okay, if we pop from this heap, the min value is 1, and then the next value that you should peek is 2. That's the next lowest one. So if I do peek now, this should be a 2. All right, so let's run the test. It's going to fail because it says heap.pop does not exist, because it doesn't exist, because I called it remove min, which I guess is kind of descriptive, but that's not a kind of standard-ish heap method. Let's just rename this to pop. And as always, I should add a little documentation here. Easy peasy lemon squeezy. Let's see what we do when we run the test. Oh, beautiful, beautiful, beautiful. So one thing that I do want in terms of the functionality is what we see here with this guard empty. Basically, if there is an empty heap, I do want there to be an error thrown if you try to pop or peek at an empty heap. So let's also include that as a test. Okay, so we're going to initialize this array with basically nothing. So the way that this is going to work is a little bit different, because expect, given its functionality, there is something here where you can actually expect a error to be thrown. So we can say to throw. The thing is, the thing that's going to be thrown here shouldn't be a value. This should be basically a callback. So I want this to be a function and not like an actual like I don't want it to execute the function, if that makes sense. So here I'm going to say, I'm going to basically give it a arrow function here that calls heap.pop, which should throw, because it's an empty array, it's empty heap. And then conversely, if I try to peek, I can also throw. So I can save that. I run my test. And sure enough, that does get found out. It is going to throw an error. What you could also do here, technically, because I don't need any arguments for these methods, I can actually just use the function, the methods themselves, as like a callback, because they're not going to get executed. If I run my test again, I should see the exact same results. So that should be fine. What happens if you do like this mix of popping and also pushing, and maybe that throws something off internally? And so I should have a test that basically ensures that if you do a mix of popping and pushing, that things are still going to work out. So let's make that. All right, so let's make a, I don't know, a random -10, 33, 99, 200, 14, and 2. Okay, just some random stuff. It instantiates with that array, and we don't want it to throw any errors right now. We can say expect heap.pop to be, so the smallest value right now is -10. So we want that -10 to be the first thing that gets popped out. And then, oh, pop is spelled wrong. And then conversely, if we peak now, the value for that should be the next lowest value, which is 2. Okay, very good. And now we can start like mixing in popping and pushing. So let's now push a new value, 1. And I'm going to kind of like do some copying here of what to expect. So if I peak this now, 1 is technically smaller than 2, so the 1 should be here. If I pop next after that, then that value should be 1. And if I peak again, that value should now be the 2. Right? So that's a little bit much. Again, let's do heap.push. We'll push 100. And at this point, I'm just going to keep popping a bunch. Okay, so okay, so if I now have a 1 on top that has been popped off, I now have the 2. So if I push 100, then the 2 should still be the smallest. So if I pop that, there should be a 2, then a 14, then a 33. The next value after that is a 99. Value after that is the 100 that we just added, and then the last value is 200, and then there should be nothing else after that. All right, so let's see if that works as I expect. Maybe I got something wrong, but that should be working. Oh, look at that. Okay, very nice. So great. It has pop. It throws an error on peak and pop. It handles a mix of push and pop. It has a push method and it has a peak method. And so now we have a test suite that we can run on whatever we want to make sure that it has the functionality we're looking for. So I'm glad that we have the test, but this doesn't speak to the fact that this is still an ugly mess that I don't love. So the first issue I'm seeing is that we have some functionality that we're not using. So this insert from an array, if I do a find, nothing internally is using it. Previously, I had expected an external source to use it, but now this is like the default when you initialize. So actually, I don't need this at all. We can just delete it. It's gone. Something else that I noticed is that I was kind of over engineering some things. Like, for example, this like one-liner to get the value when I pass in the index to just like index the array. It seems like almost more work to do that. Like I could just replace every instance of this get val with the value in the array and just grab that value instead. Let's see where that exists. Look at this. Okay, get val is 6 letters. So if I just say array and I use these square brackets now, that's actually less letters. So I don't know why I thought that was saving time, but it's definitely not helping that much. So I'm going to basically get rid of it because I don't see a real need for it. Okay, so I just replaced every instance of get val. I can now delete this over-engineered method. For my swap, I see I can probably pop a little quick documentation on this. Just make that quick. Okay, is empty. How many times do we use is empty? 2 times. Besides the definition, we use it in one place and then in another place. I feel like there's no real need for that because this is like, again, kind of excessive. I would say the point when I start abstracting that into its own function would be when there are like 3 or more instances that are separate and like there's like some more complexity than just like checking the length of the array. So here I'm actually just going to do the same thing as I did before and just kind of replace it. So again, going to remove this unnecessary. So this is actually interesting. This guard empty. I actually do like it abstracted like this. I think it's fine. I'm just going to add a quick documentation on it. Bubble up and bubble down are the workhorse of the heap. It ensures that the one requirement is in place. The one requirement of MinHeap is that the minimal value is at the top of the heap. So let's look at bubble up. So right now, bubble up, let's see when it happens. So it has a recursive call, but whenever we push, we bubble up. And then whenever we bubble up, we recursively also bubble up. Pushing is when we add a new value, and we specifically add the value to the end of the array. And then we take that position, which is the length -1, and we say, take that value and like see if the parent needs to be swapped with that child, since you're essentially trying to like move it up to the top. So let's look at bubble up and its current implementation. So first I'll add a quick doc on this. Okay, and what we have here is very nice. This is a base case because we have recursion going on. So we need to make sure we have a base case to end the recursion. Okay, so we have get parent, which is weird. I might rename this to get parent index, but actually let's just do that right now. So let's see what that's implemented here. change the symbol name, get parent index, and add a little doc on that. Okay, so let's find out where that is. Oh, it only is being used in one place, so I might cut it, but let's talk about bubble down as well. We'll get into that a little bit later. Okay, so we have the parent index, and we're grabbing the value, and we have the child's value, and we're just checking to see if this is a correct parent-child relationship. So this functionality is very long-winded, and look what we're doing. We're just kind of like doing a base comparison. So this is like one of those things that's kind of, again, over-engineered just for the sake of having a nice, I guess, name to the method. But is it really that necessary? I would argue probably not that much. I would probably get rid of this, at least for now, in the bubble up. So we're going to do that real quick just to like get rid of that. What we're basically checking, though, is if the child is greater than the parent's value. I guess I could just rewrite this then, right? Like, that seems a little excessively complicated. Let's just say the parent is larger than the child, and therefore the child is the min, and because the child is smaller, we want to bubble it. We want to like swap the parent and the child. And because we've done the swap, we now want to bubble up that child, which is currently at the parent index. So this looks good to me. Let's check out bubble down, which we should add some documentation to. There's some odd stuff going on here. Bubble down is definitely looking weird, but let's see what it's doing. So it's grabbing the parent value, and it's also getting the left child first. So it's first looking at the left side, and it's checking to see, is this index a valid index? And you see that I'm then grabbing the value off of it. In JavaScript specifically, if you grab a value that's out of index, you get undefined returned. So instead of checking if the index is out of range, I think it might be more practical to just like check to see if this value is undefined or not, instead of going through all this like excessive checking of is valid index. Also, where do we use is valid index? It is only used within this one function, and it's only 2 times. So I would say that this is unnecessary as well as this, and we can just grab that value and just check if it's undefined or not. And I can do the same thing with the right child. Okay, and then we no longer need this reference of is valid index. Again, here we're doing this kind of like excessive thing of this really long method name. I think I could just do what I did before and just check to see, is the child value smaller than the parent? And now I don't think we have any other references to this method is correct parent-child relationship. Yeah, it's only 1 out of 1. This is the only place. Guess what? Delete it. And you'll notice I have this like nested if statement, and there's no like else statement, right? So I could just add this up here, right? So why don't we just do that? And by doing that, we have removed 1 level of nesting, which is usually a preferable thing to do. So it just makes it more readable. So I'll do the same thing down here. Doesn't that look like just a little bit better? My goodness. Okay, so what's going on with this function? We are checking to see if the child, the left child, is less than the parent. And if it is, we do the swap, and then we bubble down. And when do we even use bubble down? Let's check that out. So anytime we do pop, we do bubble down. We also bubble down within itself twice. Anytime we pop, that means we remove a value, then placing the last element at the top, and then bubbling that value down. So every time we pop, we remove that top node and return that value, and then we take the last value in the array, which is this. Basically, we're popping off the array. When I say pop from the array, it's at the end of the array, and we're placing at the top, which is what we call unshift, and we bubble down from that root node essentially. So actually I have an example to show, which will hopefully showcase why this bubble down method as it currently exists is not wrong necessarily in terms of like its functionality. It will work, obviously, because this all passes our test, and I could still show that if I do npm test that everything is still, you know, working as expected there. Is this very efficient? And the answer is no. Let's check that out. All right, so here I have worked up a little bit of stuff here, and you can just follow along with this. But the thing to keep in mind is that a min heap does not mean that we are using an ordered binary search tree or anything like that. There does not need to be any real order. The only requirement is that we have the smallest value at the top. That is literally it. The idea that the left child, it needs to be smaller than the right, that doesn't exist. You can have 2 children that are like the left one is larger and the right one is smaller. That's okay. That's totally okay. First, I want to just give an example here of an array that we're going to push into our heap one at a time. And you'll notice that all these values are backwards. I'm going to start with 20, then 16, all the way up to 2 here. And so this is sorted backwards, max to min. First time we populate it is pretty easy. It's just a node of 20. The next time we push onto the heap, it actually puts it at the very end of the array, and then we need a bubble up. So right now we're going to add 16 to the bottom. It bubbles up and says, hey, is this parent, smaller or larger than me? And if it's larger, then we swap. And that's what happens here. So 16 kind of bubbles up to the top as expected. Then we'll add it on 15. Again, 15 gets added to the end of the array, and then it bubbles up. So 15 checks the parent, hey, you're larger, so we swap. And now we have 15 at the top. So that should make sense. We add 14. Again, it now is at the bottom where 20 is the parent. It gets bubbled up because 20 is larger, and then it bubbles up again to 15, and now 14 is at the top. You can kind of get a sense of what's going on here after a while. We add 10. It bubbles up first on the left side. Now it's there. Then we add 5, but 14 has 2 children already, so we now add to the end of the array, and we get 5 on the 16. It bubbles up to the 16, and then the 10, and now we have this. And then the last value being added is a 2, and that value gets added here, and it certainly gets bubbled up to the top. And then we are left with this structure. Okay, the 2 is at the top. That's the only thing that matters. We have a 2 at the top, and you'll notice that the right value here, the 5, is less than the left. That's okay, because each child effectively is its own mini heap or MinHeap. And so if you kind of like ignore everything here and you just look at the 14 and its children, it's the smallest value of that heap. And even though the 20 is on the left, 15 is on the right, it's totally fine. This is a functioning MinHeap. Okay, so let's check out what happens when we start popping off of our MinHeap. When we pop off, we pop the top or root node off, and then we put the lowest rightmost node. In this case, it would be like the 10 here, and we bubble down from there. So we put that one at the top, and then we bubble it down. So well, that's what we see here. We pop off the 2, we take the 10, and now we put it at the top, and then we bubble it down. So now that the 10 is at the top, we are trying to bubble it down, and we look at the children, and we can see that the left is bigger, so we don't need to swap that. And the child on the right is smaller, so we must swap that and continue to try and bubble down the 10. And so we have this situation, and now that the 10's here, again, we're still trying to bubble it down, but because it only has one child, the 16, and the 16 is larger than it, we're basically done. It has bubbled down as best as it can, and this is now the new structure as we pop off the 2. And we'll notice here that the 5 is at the top, which is exactly what we should have. If we pop again, this time we pop off the 5, we take the 16 and we move it to the top, and then we bubble it down. And we get into a weird situation here. So we have now a situation where the 16 is actually larger than both the left child and the right child. And so you might be thinking, well, this is a problem. What happens? Does it matter which one we pick, if we pick the left or the right? And what happens if we just do both? We just try one and then we try the other one and see what happens. So that's what I have here with this like kind of divergent logic. So first, we're going to try looking at just using the left child. If we try to bubble down on that leg of the tree. So we swap the 14 with the 16. We continue to try and bubble down the 16. In that case, the left child is bigger, so we don't need to do anything, the 20. And the right child is smaller, so we want to swap with the 15. And that gets bubbled down, and that's it. But are we done? Well, we don't have the 10 at the top, so we definitely have a problem here. We definitely don't want to just do the left side. What we may want to do is, well, consider the right side now. And so now what we're going to do is we're going to take that top value, the 14, and try going down the right side of the tree. And if we look at that, the 14 is, compared with the 10, it's larger for sure. And so we definitely want to make a swap there. And so once we do, it has no more children, and so now we're done. Now the 10 is at the top, and that's good. So now we're going to try looking at the right child first. And so if we do that, the 16 looks at the 10 and says, okay, you're less than me, we should swap. And so once we swap, we are now in this situation where the 16 has no more children, and so we could call that done. But just like we did with the other side, I don't want to just do the right side by itself. I want to also consider bubbling down to the left side as well, just in case. In this case, we now need to try to bubble down the 10. We'll see that both children are actually larger, and therefore there's no need to swap. So now we can say we're definitely done. But we'll notice that this is the structure that it looks like right now. It will be a little bit different, if you notice, from where we were if we went left first. We have 10 at the top for sure, but we have 15 here and a 14 here. But here we have the 14 and the 16. So you'll see that there is a slight difference in this implementation if we go both left and then right. Here's some observations. Well, we definitely get slightly different results, even though it still will work. The smallest number is at the top, but that's the only requirement, so that's working great. But the thing to keep in mind here is that we could actually save ourselves some time if we just pick the smallest child first. We went back here and we did the comparison of 14 and 10, and instead of going down left, we just went with the smallest number, which is 10, and then we would not need to go back. And so if you go back to the code, that is what we're kind of doing wrong here. Right now, we are going left first, bubbling down, and doing all the proper logic, but then we go to the right. So this does not feel great. It would be much better to grab the smallest child and just use that and be one and done. So one more thing I will mention is that I don't quite love this implementation for another reason, and it's the fact that we have recursion going on. And I want you to take a second to think about what is the base case here. When do we stop bubbling down? The base case here is that the parent value is smaller than both of its children, or however many children as it has. That would be when you stop. That is not explicitly clear here. Okay, like the base case essentially happens when this fails, this if statement fails. Basically, if you have no children, or this is false, that the parent value is actually smaller, as well as this one is false. Once these two are false, everything falls through and it just kind of like returns by default nothing. I don't want that. I don't like that. I think when you're doing recursion, you should really make it clear what the base case is. Basically put it at the top, make it super clear so there's no problem, no issue later on. So I do not like this implementation. We're going to refactor this. But what I would like to do is to abstract a lot of this logic into its own function that just returns which indices we need to swap, if any. And that's what I'm going to do here. So I'm going to say const swap indices equals this dot get swap indices. And you pop in the parent index. So this is like code I wish I had. We don't have this yet, but I wish I had this code here. So let's add that real quick up top here just to have it. Okay, so I would like a method. I would like a way to kind of grab the left and right child. Right now I have these separate functions. I think that's too granular. I think it would be nice to have one function that just does everything. And so that's what I'll just do here. So I'm going to say const, and I'm going to get the left child index and the right child index. This is, again, code I wish I had. This dot get child indices given the parent. Okay, so right now it's basically this, but like one thing. Okay. Okay, cool. And I think I can now remove this. I don't think anyone else is using this. Well, it's using it down in bubble down, but we won't need that anymore because we're going to have swap indices basically handle everything. So I'm going to remove these two because they're kind of unnecessary right now. Also, I think I'm going to move my get parent index and put it next to the get child indices because that's like this right next to each other. That kind of makes sense. Nice organization. There we go. Let's first grab the values. So we can actually now check to see if these values are undefined. If they're both undefined, then there are no children. Okay, so that's one thing. So if there are no children, we know to return null. Now we can consider if there are two children or only one, if there's only one child. So if, and I'm going to kind of copy some of this logic up here. So if the left child is not undefined and the right child is not undefined, then we know we have two children we need to consider. The only thing we care about is to see which child is the smallest. We always want to swap the smallest child out. So for here, we want the smallest child index. So if the left child value is less than the right child value, you can also put less than or equal to, it doesn't really matter. If that is the case, I'm going to use a ternary operator here. If the left child is smaller, then we want the left child index. Otherwise, we want the right child index. Given the logic here, if this means that there are 2 children, and we've already eliminated no children, then the else statement here will consider all the other options, which is that there is only one child to consider. In that case, and I'll kind of copy this down here, we need to check to see which one is undefined. So if undefined. So if left child is not undefined, then we will use the left child index. Otherwise, we'll use the right child one, because then that must mean the right child is the one that's defined. We don't know which value at this point to associate with that. So let's grab that const smallest child value dot array, and we add that index in. And now this is the logic for determining which swaps are going to happen, if any. Then the parent. This is the logic here. So if smallest child value is less than the parent value, then we swap. So we want to return those values. In this case, the parent index and the smallest child index. Otherwise, that's not the case. Even the smallest child is not less than the parent. Therefore, we return null. There's nothing to swap. Okay, I know it's a lot of logic here, but this is the workhorse for the heap. And now that we have this, we can now determine in our bubble down if we are going to have any indices to swap at all. So for the most part, like, we can kind of like cut this out. I'm going to kind of just comment that out for now. This is essentially our base case. If this is null, there are no more swaps to be done. We can just stop right then and there. So that's what I'll do here. So I'm going to say if swap indices equals null, we can just return our base case to stop version. Otherwise, swap indices has a value, which means that there is something to swap. And we can do a little deconstruction here and grab the parent index, which is the first value in the array being returned. I already have that value defined here. So what I'm going to do is put an underscore just to make it a slightly different variable. But we know that the child index is the next one. Then we know that once we have indices to swap, we just call this.swap. You just pop in these 2 values basically, and then we bubble down. And the thing is, we're bubbling down the parent, who is now where the child used to be. So we actually bubble down on the child index. And we'll notice here that we are not using this parent value at all, so we can actually delete that. And we can also delete all this other stuff that is unnecessary. Let's check to make sure that this is still working, and I'm going to run my test. Test. Okay, so this is interesting. It says smallest child index is not defined. Oh, you know what I think happened? Oh, I see. Okay, right, that makes sense. Okay, so in JavaScript, everything is scoped within this. When you use const, it's scoping it within the bracket. It doesn't know where where this is defined, because outside of this context, that doesn't exist. So what I need to do here is put a variable on the outside. So I'm going to say let smallest child index, and then here I'm going to remove the const so that we are actually accessing the value outside of this bracket basically. So let's npm test that, and everything is working beautifully. Now what's nice here is that this logic is something we can apply to the other bubble function, bubble up. So let's go to that. We're doing a lot of this thing where we have a base case, which is great. We're bubbling up the child index, but we're still doing this thing where we're checking to see if a swap is necessary. Do we need to be doing all this thing where we're checking the parent or whatnot? So I'm going to call on my function, which is called this.get swap indices. And it takes the parent index, actually. So we actually do need this here. So I'm just going to kind of grab that to get the parent index and pop that in. And this will be our swap indices. Actually, I can just kind of copy that, right? So for this bubble down, I am going to kind of just copy this because I think that's basically the same thing. Okay, so if we have swap indices, this is not really a base case because it's not stopping the recursion. This one is. It's still, valid to do that. And otherwise, we will deconstruct this and then we will do the swap on the parent index and the child index. Now, the slight thing that's different here is that when we do bubble up, and remember when we use that, we use it on push. So that's when a new value is being added. The thing to kind of keep in your mind is that the structure of the heap, whenever we're doing bubble up, is such that the only value that has like any uncertainty is that the child that's kind of being added and being bubbled up. Nothing else is like in question. So when you have the swap indices logic working and you're getting this child index and parent index, the only time that this is going to happen is when that child, which is the new child, is the thing being swapped. So this child index and this child index are essentially the same thing. So here I will actually put underscore in front of the child index because we already have that essentially. And the parent index is sort of like the new one here. So effectively, we're only checking to see if just this child and its parent are going to be swapped. So the logic is a little bit simpler, but we can still use the same functionality in this case. That's what we'll do here. We're going to swap these if these exist. So I'm going to pop that down here. We don't want to bubble down here. We do want to bubble up. And the thing we're bubbling up, though, is not the child index, but the parent index, because that's where the child is, the thing that's like still kind of in question. So that's what we'll do there. And we no longer need this logic because it is bubbling up properly. And that's basically it. So let's save that. Let's run our tests just to make sure. And everything is passing beautifully. Okay, there's, I think, one last thing I will do, which is to kind of organize things. Everything's a little bit all over the place. I think I'm going to put like things with like, push, pop, and the peak. So all these main functions I'm going to put at the bottom. So push, pop, and peak. I'm going to put the bubble up and bubble down next to each other because I think that makes sense. Bubble up, bubble down, cool. This, I think, is my implementation. The one that I would do nowadays, this is kind of what it would look like. It has documentation. I kind of maybe went overboard on the documentation, but whatever. It's still better to have it than to not have it. And then I also made sure to make efficient use of my space, that I'm not going to be kind of like over engineering things, and definitely abstracting the logic where it needs to be. Like this being the main workhorse is really nice to have. Anyway, folks, that is it for me today. I hope you enjoyed this. If this is the kind of content you enjoy, make sure to like, subscribe, do all the good things, and I will see you next time. Take care.